7.2 is going to get into some special cases of right triangles, and these are really shortcuts. The Pythagorean theorem always works for every right triangle, but you always have to know two sides. So what these special right triangle rules do is they allow us, in certain cases, to get by with only knowing one side and still solving. So our first one is a 45, 45, 90 triangle. And what the 45, 45 refers to are the two angles. And if you think about those two angles being equal, that means the legs have to be equal. So what we're really talking about here is an isosceles right triangle. Now, in words, what this special rule, the shortcut, says is that the measure of the hypotenuse is the square root of 2 times the measure of a leg. That seems really confusing even to me. If we call our leg L, and they're the same, we call our hypotenuse H, what this is saying is that the hypotenuse is equal to the leg times the square root of 2. If you know that formula, you can find all of the measures of this triangle given one of them. If you know H, you put it in, divide by the square root of 2, find L. If you know L, you put it in, and you have H automatically. Very slick trick. Now we can also use these special rules for 30, 60, 90 triangles. Again, the 30, 60, 90 refers to the angles. Now it creates some special relationships. The 30-degree angle is always opposite the shortest leg. The 60-degree angle is always opposite the longest leg, and the hypotenuse is always where we expect it to be. Now, in words, it says the measure of the hypotenuse is twice the measure of the shorter leg. There's our first formula. And the measure of the longer leg is square root of 3 times the measure of the shorter leg. Again, that sounds like a lot of words and very confusing, but it boils down to two simple formulas. The hypotenuse is twice the measure of the shorter leg. So the hypotenuse is equal to 2s, 2 times the shorter leg. The measure of the longer leg is equal to the square root of 3 times the measure of the shorter leg. So the longer leg is equal to the short leg times the square root of 3. So again, these two formulas are a shortcut to the Pythagorean theorem in solving 30, 60, 90 triangles. So let's look at some examples. This first example doesn't look like we have enough information, but with those two sides marked, it means it's isosceles right, which means this is 45 and this is 45 because base angles of an isosceles triangle are equal. Well, if these two are equal, that means that side is also 3. So now I just need to solve for my hypotenuse. In a 45, 45, 90 triangle, if you remember, the hypotenuse is equal to the leg times the square root of 2. This is the leg substituted in for right here, and the hypotenuse is equal to 3 square roots of 2. And that is all there is to it. If we look at this next example, which happens to be a 30, 60, 90 triangle, with this angle being 30, that means here is my hypotenuse. I'm missing my long leg, and I know my short leg. If I want to find my long leg, my formula said the long leg is equal to short leg times the square root of 3. Substitute the value of the short leg in. My long leg is equal to 8 radical 3. And my triangle is solved. A lot faster than the Pythagorean theorem. Now you can use the Pythagorean theorem to check these answers if you want. Example C. This is a 45, 45, 90 triangle where I know my hypotenuse and I want to find my legs. Now what does my general formula say? My general formula says the hypotenuse is equal to the leg times the square root of 2. Well, in this case, we're going to substitute in the hypotenuse because that's what I know. 4 radical 2 is equal to the leg times the square root of 2. Divide both sides by the square root of 2 because I want to isolate that leg. These two cancel, and my leg is equal to 4. Again, keep in mind, legs should be shorter than the hypotenuse. The shortest leg in a 30, 60, 90 should be the smallest side, then the long leg, then the hypotenuse. So an answer of 4 makes perfect sense. In example D, I'm dealing with a 45, 45, 90 triangle, where these two would be my legs. So that means that this side here is 15, and I need to use my formula to solve for h. And it says h is equal to the leg times the square root of 2. What do I know? I know one of the legs. Put that into the formula, and the hypotenuse is equal to 15 square roots of 2. Now E is a 30, 60, 90 triangle. It's always a good idea to make some sort of a note to yourself what is what so you don't get confused. Here I know the long leg, so I need to find the short leg and the hypotenuse. So the short leg times the square root of 3 is equal to the long leg. That's my formula. Substitute in the long leg. So I have short leg square root of 3 equals 15. Divide both sides by the square root of 3. So I have s is equal to 15 over the square root of 3, but we know we have to rationalize our denominator. That's why we practiced that skill. So we have 15 radical 3 over 3, which simplifies to 5 radical 3 for our short leg. Once we have that, then we know that our hypotenuse is equal to 2 times our short leg. We know our short leg now, and so our hypotenuse is 2 times 5 square roots of 3, 10 square roots of 3. And that is how you work through. Now in this particular case, you can't get directly from the long leg to the hypotenuse. You have to go through the short leg. It's the only way to do it. Now, letter F is back to a 30, 60, 90 triangle. In this case, we're given the short side. We don't know the hypotenuse, and we don't know the long leg. So short side to the long side, well, short side to hypotenuse, let's do that first because that's easy. 2 times the short side is the hypotenuse. So 2 times 5 is the hypotenuse. So the hypotenuse is 10. Second part of our problem is the short side to the long side. And we know that the short side times the square root of 3 is equal to the long side. Our short side is 5. And that is all that's required. Our last two examples of these. G is also a 30, 60, 90 triangle. Missing hypotenuse. I know the long leg, and I'm missing the short leg. So given the long leg, I know, first step, that short leg times the square root of 3 equals my long leg. Substitute in what I know. The short leg times the square root of 3 equals 14 square roots of 3, because that is given. Divide both sides by the square root of 3. Cancel, 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 and s is equal to 14. Once you have the short side, we remember that 2 times the short side is the hypotenuse. So 2 times 14 is the hypotenuse. 28 is the hypotenuse. This is also a great point where showing your work and the logic in your work is very important because that second answer of the hypotenuse hinged on your first answer. So partial credit will be very important. Example H is also a 30, 60, 90 triangle where I'm given the hypotenuse. I don't know that long leg or the short leg. So first step, 2 times the short leg is the hypotenuse. Substitute in what I know. 2 times the short leg is 12. Divide by sides by 12, and S is 6. Now, once I know the short side, we know that the short side times the square root of 3 is the long side. Substitute in what I know. 6 square roots of 3 is my long leg. In looking at a different kind of problem, find the length of AC. Now, it's pretty tempting, and it would be fine. Again, we know that this is isosceles perpendicular bisector. I know from here to here is 4. You could go ahead and use the Pythagorean theorem to find this side right here, which I'm going to call L for the long side. But let's go ahead and use the 30, 60, 90 rules. I know the short side and the hypotenuse. Short side to long side is the easiest because I know the short side times the square root of 3 is the long side. If the short side is 4, that is all it takes. If you think that my new shortcuts aren't that good of a deal and you went ahead and did 4 squared plus L squared equals 8 squared and said 16 plus L squared is 64 and L squared is equal to 48 when you subtract 16 from both sides. L is equal to the square root of 48, which is 16 times 3, and so L is 4 radical 3. It's pretty clear